Okay, here's something I did in 164 Calculus, which was the second semester of calculus at a prominent school of mathematics. I have the transcript of my grade to prove that. I took 4 semesters of math at this school, and I made straight A's in mathematics. Okay, now I want to find a reduction formula for sine to the nth of x dx. I did this in calculus 164 as an extra credit, and I was the only one that got it right. I was the only one that was able to actually do this problem, and it just blew everybody's mind. So I got all the questions right, plus I got extra credit light. So I'm going to write this as integral of sine n minus 1 of x sine x dx, like that. Okay. Now, if I write it like that, by the power rule, you have sine n minus 1 x times sine to the first power x. 1 plus negative 1 goes to 0, and you still have sine to the nth of x dx, right? Okay, that's the power rule, it's called. All right, so with that in mind, I also remembered that ddx of let's say sine squared x, to get a generalized rule. Well, how am I going to do that, you think? Well, I wrote it like this: dx of sine x times sine x, like that. And I used the power rule in calculus to take that derivative. So I said the first times the derivative of the second, plus the second times the derivative of the first, is just going to be sine first times the derivative of the second, cosine x, plus the second, which is sine x, times the derivative of the first, which is cosine x. And I said, wow, that's pretty cool, because that's just going to double up. Right? And this power here is going to decrease by 1. Okay? So that's important. So in other words, in general, you're going to have dx of sine to the nth of x. This is just the derivative. In general, is going to be n times sine n minus 1, that power decreases by 1, of x cosine x. I made that observation. Okay, so now I'm going to rewrite my original function. I'm going to have the integral of sine to the n minus 1 of x sine x dx. And I want to have my dv at the lowest power. So this power is 1, because n minus 1 plus 1 just gives n back again. So I'll choose my dv automatically. No, my dv is going to be chosen to be sine x dx. Okay. And now I have to choose a u, which is going to be sine. The only thing I have left to choose is sine n minus 1 times x, right? So u equals sine n minus 1x. Okay, so du equals the quantity n minus 1 times sine n minus 2 of x cosine x. Because remember, in general, see, like I had the derivative of sine to the nth of x is n times sine to the n minus 1 of x cosine x. Well, here I'm using n minus 1 to start out with, so I get, for my n, I'm going to replace it by n minus 1, and for this n minus 1, will give sine n minus 2x cosine x. And that is going to be with a dx next to it. Okay? Now, what I did when I took that calculus course is I looked at my integration by parts, integral of u dv equals uv minus the integral of v du, which I have a very eloquent way of proving that as well, which I'll do later in another video. But anyway, so what I'm going to do is I'm going to say that sine, I'm going to write this way over here, because I'm going to need a lot of room. Sine n minus 1 of x u times v, okay? If dv equals sine x dx, then v, if I integrate both sides of this, the antiderivative of sine is negative cosine x, like that. Negative cosine, see? Right there. So I'm going to put this negative cosine here, but I'm going to take the negative sign out here. I'm going to put cosine x minus the integral of v du. Okay, v is negative cosine, again. So I'm going to put integral of negative cosine right here times du, which is the quantity n minus 1 times sine to the n minus 2 of x cosine x dx. Well, you're going to have two cosines here, right? So they're going to square, because anything multiplied by itself just squares. So I wrote this as sine to the n minus 1 of x cosine x plus two minuses, make a plus. The integral of this n minus 1 times sine n minus 2 of x times cosine squared x dx. Wrote it like that. Okay. So now I'm going to rewrite all that again, and I'm going to set it to the integral of sine to the nth of x dx. Okay, so I'm going to write all that again. And I'm going to set it equal to, I'm going to have the integral of sine to the nth of x dx, like that, okay, equals this negative sine to the n minus 1 of x cosine x plus, I'm going to take the constant outside, which is n minus 1. It's a plus. The integral of sine n minus 2 x. I'm going to write the cosine function that's squared, cosine squared, as 1 minus sine squared x in parentheses with respect to x. So that's a lot right there. But it's 1 minus sine squared x. 1 minus sine squared x is going to be cosine squared x. It's the same thing. You get that from the unit circle derivation, which says that cosine squared x plus sine squared x equals 1. So here, I'm going to have this 1 minus sine squared x dx multiplied by the sine to the n minus 2 power of x. Okay, now I'm going to start simplifying everything. And I'm going to have the integral of sine to the nth power of x dx equal to negative sine to the n minus 1 of x cosine x plus this n minus 1 times all this integral of, now sine to the n minus 2 times 1 is just sine to the n minus 2 of x, and then sine to the n minus 2 times sine square is just going to give you your sine to the nth power back. Okay, so I'm going to write this as the integral of sine to the n minus 2 of x minus the integral of, okay, and this is with respect to x. I have to write that. That's very important because I'm going to separate it is what I'm doing. This this minus the integral of sine to the nth of x. How do I get that? Sine to the n minus 2 times sine squared is just going to give you your sine to the nth power back dx. This is hard because I'm doing it on paper. But anyway, I'll finish it. So now I have the integral of sine to the nth. It was hard in calculus class too because we had to do it on paper. We didn't have a lot of room, but I did it. I was the only one in the class that did it. Sine, there were still other A's, but I got the highest A because I did this. I got the extra credit. Sine x cosine x plus n minus 1 of this well, I'm gonna do this. I'm gonna try to factor this out. This sine, well, I gotta iterate this integral of sine to the n minus 2 of x dx, and I'm gonna bring this n minus 1 multiplied by the integral of sine to the nth power of x dx over to the other side. But I gotta write it here first before I do that. So let me write it. Minus n minus 1 quantity times this integral of sine to the n of x dx. Okay, so I took this n minus 1, this negative n minus 1's integral sine n x dx. I got to bring it to the other side. So I have to say that n minus 1 times the integral of sine n to the x dx plus this integral of sine. Let me just find that first real quick, and then I can write it all out. Okay, now this is going to be, if I multiply n times this, I'm going to have n times sine to the x dx, n times the integral of that, minus this integral of, it's just 1, so minus this integral of sine to the n power of x dx plus this integral of sine to the n power of x dx. So what's going to happen here, this is going to cancel with this. Okay, that's what I want. Now I can write it all out. So when I write it all out, here's what I'm going to get. I'm going to go ahead and complete that. So if I have that, I'm going to have n sine to the nth of, like that. Oh, let me write it again. N times the integral of sine to the nth of x dx equals this when I simplified it, here it is. When I simplified it, I'm going to write it all out. When I simplified it, I got minus sine to the n minus 1 cosine x plus n minus 1 times, I still have the integral of sine n minus 2 of x dx. See, these derivations are not simple. Okay, so I have n times the integral of sine to the nth of x dx equals negative sine to the n minus 1 of x cosine x plus n minus 1 times the integral of sine n minus 2x dx. So when I divide through by n, I'm going to get the integral of sine to the nth of x dx equals negative sine n minus 1 x cosine x divided by n plus, oh, I kept track of all that stuff, n minus 1 over n times the reduced formula, the reduced form, rather, of n minus 2x dx. And now I want to test it. Oh no, I'm not done yet. Now I have to test the reduction formula. And you can find this in any calculus book that's advanced, that has a list of the integration formulas in it. It's called the reduction formula for the sine function. Sine function. Table of integrals. So you got the table of integrals, and you look for the reduction formula for the sine function. Okay. So that's what you might want to do to verify that this is correct. But I'm going to verify it anyway. I'm going to verify it by first solving a integral problem. Now this is good for n greater than or equal to 2. So I'm going to set n equal to 2, and I'm going to see if it works for n equal to 2. Man, I'm the type of guy, I like to prove that what I derive actually works, because it's just like science. If you have a hypothesis and the hypothesis is proven to be false, you throw it away, right? It's not any good, right? Obviously, that's true. Okay, so I'm going to set n equal to 2, and I'm going to integrate sine squared x dx two ways. The first way, I'm going to say that I'm going to set sine squared x using the double angle formula equal to 1/2 1 minus cosine 2x. and I'm going to integrate that. Straightforward integration. And then I'm going to use the reduction formula and see if I get a match. If I get a match, then that means it works. Okay, so now I will integrate this 1/2 1 minus cosine 2x dx. I'm going to set u equals 2x, du equals 2 dx. Okay? So then I'm going to have dx equals 1/2 du. Okay? So I'm going to integrate straightforward. So I'm going to have 1/2 the integral of 1, which is just x, minus 1/2 the integral of this okay, I have 1/2 out there, so it's going to be 1/2 times this 1/2, because I was multiplying 1/2 by both of these. So 1/2 x minus 1/2 times 1/2, because you got 1/2 du, okay, of cosine u du. Now I'm in u world. Okay, so now I'm going to get 1/2 x minus, okay, plus 1/4. Oh, and this is that right? Yeah, cosine equals sine. Yeah, that's right, 2x plus c. Because I let u equal to 2x. So I got to put a 2x back in there for u, right? So now, well, what about this sine 2x? Can that be reduced? Well, sine 2x by the double analytical formula for sines equals this 2, you can check this up with trigonometric identities, 2 sine x cosine x. 2 sine x cosine x. Okay, so sine 2x equals 2 sine x cosine x, putting everything in the single power formula. Okay, so I'm going to rewrite this as 1/2 x plus 1/4 2 sine x cosine x. So this is going to go to a half, because 1/4 of 2 is just 2. And then I'm going to have sine x cosine x. Okay, and this is what you deal with when you get in higher mathematics. So that's going to actually equal to the integral of sine squared x dx equals that. Okay, now we use the reduction formula to find that. Okay, so if I found that the integral of sine squared x dx equals 1/2 x, integral of cosine, oh, that was supposed to be, yeah, that's right. Okay, the integral of cosine is just sine, so that's supposed to be a minus out there. Ah, I caught a mistake. So now it's right. Good mathematician always goes back and checks everything to make sure that he's right, or she. So I have the integral of sine squared x dx equals 1/2 x minus 1/2 sine x cosine x. Okay, now if I use the reduction formula, which I'm not going to write out again because it's if I use the reduction formula, let's see if I get the same answer if I use the reduction formula. I should get the integral of sine squared x dx equals 1/2 x minus 1/2 cosine x sine x, or sine x cosine x, or rather. Okay, now if I use the reduction formula, I'm going to get, well, I set n equal to 2 for the reduction formula. So I'll get negative sine n minus 1, 2 minus 1. I'm just going to write as sine x cosine x, because here's the formula. Minus sine n minus 1 x cosine x, but n equals 2, so 2 minus 1 is 1. Okay, so I got that part. And then I have also got, here's the reduction formula right here. That's the reduction formula. Okay, so now I have the sine x cosine x right there with a minus sign out, and I'm going to say it's over 2 according to the reduction formula. Okay, and then I say I have n minus 1, 2 minus 1 over 2. Well, 2 minus 1 over 2 is just a half. So I'm going to have this plus 1/2 the integral of n is equal to 2. Okay, so in the reduction formula, n minus 2, 2 minus 2 is 0, and that's just 1. Anything raised to the power of 0 is 1. Sine is no exception. Sine to the power of 0 of x is going to be 1, so it's like integrating 1. So you got the integral of 1 dx, which is going to be x, right? So now you're going to have 1/2 x right here when you integrate this, minus 1/2 this negative sine x, negative sine x cosine x. Okay, so you're going to have a plus here and a minus here. So now you're going to have 1/2 x minus 1/2 sine x cosine x, which is clearly the same thing I got right here. Okay, I got 1/2 x minus 1/2 sine x cosine x using the trigonometric substitution of, see, I used 1 minus cosine 2x, 1/2 of that for sine squared x. And I integrated straightforward, and my answer, I came up with my answer as 1/2 x minus 1/2 sine x cosine x. And then I used the reduction formula, and I came up with my answer as 1/2 x minus sine x cosine x. And both of them have a c next to them, because this is a definite integral. Okay, I mean indefinite integral. This is an indefinite integral because it doesn't have limits of integration, so there's a constant there. So the answer to the integral of sine squared x dx equals 1/2 x minus 1/2 sine x cosine x plus c, using the half angle formula. I discovered that. And then when I used the reduction formula, which is right here, I used this formula here, and I plugged everything in. I ended up with the same answer. The integral of sine squared theta. I mean x, sorry, not theta. With respect to x, the integral of sine squared x dx equals 1/2 x minus 1/2 sine x cosine x plus c. So that was using the reduction formula, okay? So I did it two different ways. I used the double angle formula, and I got the answer both times. I got integral of sine squared x dx equals 1/2 x minus 1/2 sine x cosine x plus c.